Hi, everyone. My name is Dami Arimo. I'm a project management intern for Applied AI projects. During the course of my internship, I worked on a couple of projects, and I'll be talking about the project Anomaly Detection today. So right now, there are 4 stages of the project. We have the ideation, preparation, execution, and distribution. Anomaly Detection is currently in its ideation phase. Today, we're going to be talking about the project overview and the benefits of this particular project, what exactly anomaly detection is. I'm going through a few use cases and then deliverables of the project. And then we're going to be having like a question and answer session. So the project overview, this particular project is going to be a bootcamp format for the anomaly detection project. And the objective is to ensure that participants are able to explore the potential of anomaly detection methods in real life scenario. Secondly, they're also going to be able to get access to reference implementation, that's the GitHub repositories, including full examples, and then build a proof of concept with the support of the Vector Institute. And lastly, they're going to be also able to explore the suitability of state-of-the-art techniques. So what are the benefits of this bootcamp? Starting from the left-hand side, they're going to be able to explore the application of anomaly detection in various business cases, various business use cases. Secondly, they're going to be able to understand the latest techniques and methodologies of anomaly detection. And then there'll also be a transfer of knowledge from the Vector Institute to, our sponsors. Then to the right-hand side, we're going to have access to the latest techniques of anomaly detection. They're going to understand the place of anomaly detection in solving business problems. And lastly, have a potential of developing a quick proof of concept. So what exactly is anomaly detection? Anomaly detection is a task in machine learning that detects unusual patterns or observations in data that deviate from the expected behavior. So anomaly detection it involves identifying samples that differ in some way from the training data by modeling the distribution of the training data during training and checking whether the new samples conform to the defined training during an interference. Anomaly detection is applicable with various types of data. We have image data, like in the health industry for brain scan. We have video data that can be used in the transportation industry. We have text data that are used by email service providers. And lastly, we have tabular data that can be used for fraud detection in banking and finance. So what's the problem formation? In this particular image, we can see pedestrians and cars. So in this problem, we say that the pedestrians are considered to be normal, while the car is considered to be an anomaly. So F produces a representation of the given data pedestrians, which are marked by the green dots that we have on the right-hand side, follow the distribution of the target class. Thus, the car indicated by the red buttons to my right is known as the deviation or the anomaly in this case. So by measuring the D, the calculated distance of the car from the normal data is known as the deviation. So I'm going to be talking about some example use cases. For image data, we have brain tumor detection. So for brain tumor detection, there's a training of regular data, normal brain images and all of that. And then we are going to be checking if there's an abnormality or anomaly in the brain scan. Then secondly, surveillance and security. This is the process of checking if there is a deviation from what is the norm in transportation industries and the likes. Then lastly, industry inspection. So a set of normal pictures are put in the anomaly. So whenever there is a deviation from this normal set of pictures, we say that there is an anomaly in the particular products. Then secondly, we have text data. So for text data, we have fraudulent reviews. This is the process of seeing unusual activities in reviews, and this can indicate an anomaly or a fraudulent or fake review. Then we have spam message detection. This is used by mail services that can detect if there's an unusual activity or unusual links and unusual messages in in a message content to show that it might be a spam message. Then lastly, if there are unusual activities or unusual news or unusual links in the fake news, it can detect that, oh, this might actually be a fake news detection. Then lastly, we have tabular data. From the left, we have network intrusion. This involves identifying unusual network activities that might indicate a security threat. Then we have sensor monitoring, identifying unusual sensor reading. This involves identifying unusual and unexpected reading from sensors that might indicate a problem or a malfunction. Then lastly, we have fraud detection in financial institutions, financial transactions. This involves identifying unusual patterns in transactions that might indicate presence of fraudulent activity. So what are some anomaly detection success stories? A lot of companies have used anomaly detection to better improve their processes, to improve their operations and protect their customers. Capital One and PayPal have used anomaly detection to detect fraud in their transaction, reduce financial losses, and improve customer trust, while Amazon has used it to monitor its network and prevent outages. Honeywell and Siemens has used it to monitor and maintain their industrial equipment and reduce downtime and maintenance costs. Lastly, Cisco used anomaly detection to monitor its network traffic and then detect potential cyber threats, improving cybersecurity defenses and preventing cyber attacks. So for this bootcamp, the proposed method and techniques, we have a lot of them that we intend to use for the bootcamp. We have the non-deep learning based methods, reconstruction based methods, and going down the list. So the deliverables for this particular bootcamp, we're going to be developing a demo and reference implementations to address the different use cases that the sponsors are going to have to deliver during the bootcamp. Then secondly, we're going to be working towards developing open source Python packages that address the shortcomings of existing solutions that are already in the market. Then lastly, we're going to be using the feedback from the bootcamp to access and redefine future sets of package and determine if it is worthwhile to bring to the larger audience. So what are the next steps? We're going to be socializing the idea to relevant stakeholders and identify the use cases of the participants and the data set that are going to be used for the bootcamp. And then lastly, we're going to be confirming the participation of the bootcamp. Thank you.
Thanks so much, Dami, for the presentation. So my question is, you mentioned a lot of really interesting use cases about anomaly detection. So I can imagine that, when your sponsors come to the bootcamp, they might have very different use cases. For example, some might be doing computer vision, some might be trying to do like text analysis or finance, that type of thing. So how would you accommodate, I guess, all of these different types of use cases in one bootcamp?
So it depends on how many participants we are able to get. But if we have a lot of participants, we'll have to segment them into different categories. So those that want to look into image data, those that want to look into text data, we are going to have to segment them into different groups so that we can focus on what they actually need for their use case.
A little bit. Okay. Or at least in your experience thus far, has there been maybe a consistent subclass of ML that a lot of the sponsors care about? Has there been more computer vision approaches for anomaly detection? Is text extraction or detection an emphasis? I'm not sure how many people you've spoken to about this yet.
So from the research, the major one, but probably because the users are a lot more, is fraud detection. So like most financial institutions and all of that, PayPal and the likes want to really know how to detect fraud in their systems. So I would say that tabular data is actually one of the most popular ones right now that we might be really looking into for anomaly detection. Then probably after tabular data, we can look at text data as well to ensure that we have everything, weeded out.
Gotcha. Thank you.
Thank you.